Thanks everyone for sticking around for this lightning talk. It's only 10 minutes, and I promise it's going to be interesting. So we've seen an impressive list of a very vibrant tooling ecosystem for Scala, and I think Develocity fits right in. I'm sure that if I ask people to raise their hands, if they wish SBT was easier to understand, and if there was a tool to make it easier to troubleshoot your SBT builds or make them faster, or even collaborate with. Every company has an SBT guru that knows a lot about SBT, and everyone goes to ask him. So if there was a tool to do that, I think that's Develocity. So let's dive right in. And before we go deeper, I'll say it from the beginning. This is a commercial tool, but it is. We have free licenses for open source organizations. Apache has one, Spring has one, and so on. So we want to support the Scala ecosystem as well, and individuals can also use it without too much hassle. So what does it do? We call it a build observability and acceleration, and it supports 4 build tools, so SBT, obviously, Gradle, Maven, and Bazel. It has its roots in Gradle. It started about 7 years ago as a tooling to help Gradle developers understand their builds and make them faster. And it is today used by very large organizations like Netflix or Airbnb and so on, but also small ones, and it works well with monorepos, but also hundreds of repositories. So what does it actually do? So on the left, we see one big part of the functionality that we call a build scan. And this is like an X-ray for your build. It collects everything that happens during the build, and it displays it into a UI that is easy to understand, it's shareable, and you get task-level analytics for a single build execution. So you have separate sections for tests, for failures, and so on. We'll get to a demo in a bit. But there's a second side, which is, if you wish, build scans integrated over time. So we call them dashboards, and they are analytics and insights across thousands of local builds. You can see the trend of your build times, the trends of how long it takes to run your tests, how long you spent uploading things to the build cache or downloading, or how often you missed the cache, or just time spent on downloading dependencies, which sometimes, or resolving them. Now let's see how would this work for SBT. It's fairly simple. So all you need to do is add an SBT plugin. This is the setup you need to do. And if you want to publish to the open source, let's say a free public instance, scans.gradle.com, that's all you need to do. You just run SBT, compile, run, whatever you want. And then at the end of the build, you'll get a link that you can open and see something like in the screenshot above. But most of our users or customers would have an internal instance, so you would have a bit of configuration to add to your build SBT, in particular authentication probably, and the URL where to push this. So I have a screenshot, I have a demo, so we'll see how we're doing with time. Test analysis is, in my opinion, one very interesting and very useful part, because you can see all your tests. So here I see how much time I spent on the test, and I see 2 flaky tests. And no matter how careful we are, there will be some flakiness in our tests. You can see also the trends of these, and we detect flaky tests by automatically retrying. You can configure, of course, if you want this or not. And then if we see that the test passes on a second or third try, we'll mark it as flaky, and you'll have a record, and you can actually go back and see what are my tests that have the highest degree or a percentage of flaky runs, and I can go back to the teams if it's a monorepo, and I can tell them, hey, please fix this test, or I can disable them, perhaps. I can also search for them, go for the slowest tests. We'll see that in a demo. Another thing that is also pretty good if you want to optimize your build, we have a timeline view that shows all the tasks that SBT ran in your build with the different threads. There's a lot of parallelism in an SBT build, hopefully. But if you go, you can drill on various tasks, and you can get a lot of details about including its dependencies, reverse dependencies. You might know this from the inspect command in SBT. But this is there all the time, so you can go back in time to a build that failed half an hour ago, or maybe during the night on the CI, and you can go and drill down and find all these details recorded for you. So the dashboards and trends, I touched on them at the beginning. These are the sort of integration over time, so we can see how the build times are going and how much time is spent on various parts of the build. I mentioned in the beginning that we do build observability, but also acceleration. So there are 4 main areas where we can try to speed up the build for SBT. The first one is the Hydra parallel compiler, which is a product that we developed while I was at Triple Quote. It supports only Scala 2 for the moment, but it's a way to parallelize a single module, so it goes deeper than SBT. It's not task level, but actual file level parallelism. Then we have test distribution, which is a way to run your tests on different agents that can run in the cloud. So you can distribute your test runs and speed them up in this way by running them on many machines. Predictive test selection, this is a way that we use machine learning to detect or reduce the amount of testing you're doing in a build based on historical data. So some tests never fail for certain types of changes. And even though if you take the build level dependencies, you should run them, we can speed up, let's say, pull requests by not running those tests, and you can run them on main. And the last one is a remote build cache service, which is something we're actively working today. So we should have this very soon. And I just want to make a little announcement. So Martin Duham, my colleague, is going to have a technical talk about this topic at 5 p.m. today. So I think it's going to be a very interesting talk. Just try to go there. So let's try a little demo, if I find a way. So this is a Scala 3 build. So I ran tests on Scala 3. I see immediately that I had a couple of test failures. So I can scroll down, and this is basically the summary page. So I have everything in here, including an infrastructure section that would tell me the operating system, Java version that it ran, and so on. Not super interesting. It also tells me a couple of flags. Did I use Coursier? It's on. Is the semantic DB plugin enabled? It's not. These are relatively standard SBT settings that we collect. And if I were to go further, let's say the console log, I would see everything that happened, and I can link to any line and send it to a colleague. Hey, can you help me understand this error here? And just send this link. On the failure page, one interesting thing is cross-referencing. So I can see 15 other builds with similar failures in the last 7 days. If I click on this button, it will take me to those failures, and I can see if there's anything in common. Perhaps they only fail on macOS, or perhaps they only fail on one particular machine in the cloud if these are CI builds, and so on. On the tests, obviously it's all here. I could probably start by looking at the slowest test, and I see 1.5 minutes is in idempotency tests. Maybe I can drill down and see if I can break this into smaller chunks that could run perhaps in parallel, or maybe I just find out something interesting that makes it faster. For the timeline, I think this is not a very interesting execution because, well, I guess my internet is a bit slow. No, I just need to scroll. Almost all the time was spent in tests, but I have another one that looks a little bit more interesting. I can see that it compiles Scaladoc in parallel with the Scala 3 library bootstrapped JS, which is a good thing. And if I click here, oops, I can see a few things like its dependencies, what it needs in order to start running, what it depends on it, only the compile Scala backend task. And if I click on this one, I think this is an interesting feature. It will take me to the console log, but it will filter the output for only the output produced by this task. So that's pretty neat. It didn't produce much output either. Custom values, okay, this one doesn't contain any. I can attach things to my build scan in my configuration. So I can add, for example, here, the Scala version. But I could add anything that would be interesting. Perhaps if I run this on AWS, I would add, well, this ran on AWS. So this, I guess I touched on this already. These are the dashboards. So if I go for tests, I would see that builds with flaky tests, I have 12 builds in the last 7 days. All of them happened on March 18. I see a lot of builds with failed tests also on March 18, so I guess there was a spike in, in development, and I can go and see, okay, this is the particular test that was very flaky, forking 3 example test. I can click, find the individual runs, I guess. Let's see this guy. Yes, I see the actual run, and I can go and open the build scan associated with it. So I can go back to this view, and I see it passed. Well, I guess this is reversed. It failed on the first run. Well, they have the same timestamp almost, but yeah, it needed 2 tries to pass. So I think this is all for the demo. I just wanted to show that this actually led to one of my colleagues to open a PR to Apache Peco and fix a bottleneck. It's very visible in this timeline view here. Well, the whole build was basically stopping, waiting for this task to go until it could do all the other things. It's very well parallelized otherwise. It's an amazing build, except for this bottleneck. So I'm going to stop here. Try it out for yourself. You don't need to register. You don't need to do anything except just add your plugin, follow the instructions there. Come to our booth. We'll be very happy to give you a demo or talk more about it. Thanks a lot, and yeah, see you at the booth, I hope.
Thank you so much.